So I want to introduce the team for the Lower. Yeah, thank you. Want to do a brief introduction of our team for this panel, and this is Lower Manhattan Coastal Resilience at the Battery. We have here Stephen Nelson, Assistant Vice President from EDC, who is on the client team for this project, myself on the design team, Ethan Smith, who is the working with Hunter Roberts Construction Group, part of the CM team, and then Grace Tang from Parks, also part of the client team. And so I will pass it to Stephen to kick us off.
Hi, good afternoon. Sorry. So, you know, why we're all here, due to Superstorm Sandy, I don't really need to go through the facts, so you guys all know everything, but you can see the sort of devastation and why this project is why it is. I'm sure most of you have seen this image before of all of the projects that are ongoing in Lower Manhattan for the coastal protection. We are right here at the Battery Coastal Resiliency, just south of here, on the other side of Pier A, so always happy to have visitors. And you also are all aware of the HAT study, which this will be incorporated into, as the other Lower Manhattan projects will be as well. I think this is you.
Hi, good afternoon. So just to give everybody a little bit of context, this project actually not only Superstorm Sandy kind of instigated the work that we're doing, but it actually started with a waterfront inspection that we did. And so the waterfront wharf at the Battery was really in really poor shape. There were sinkholes. It had to be reconstructed anyways, and so we took the opportunity to do a full reconstruction and think about sea level rise and climate change and how to adapt the new wharf to climate impacts. Here you can see we're in Lower Manhattan at the very tip. It's one of the larger green spaces down here, so really valuable asset to the community. And so it just has a lot of history here as a fort. It's a confluence of several water bodies, East River, Hudson River, the New York Harbor. And so just the site itself is just very special. And so we wanted to make sure the work that we did here was sensitive to that context and the history. And something also worth noting, important program that occurs here at the wharf is the Statue of Liberty ferries. They leave here. So that was a really key piece of the program that we developed for the park. Next slide. Oh,
I got it.
thanks.
Oh, this is, I will jump back in. So out of this project, we consider this project the pet guinea pig for the EDC clean and circular construction guidelines that are now a part of all of our RFPs going forward in the future. So really this document probably would not have been possible if it weren't for the work that we've done on this project with all of our material reuse and our approach to sustainability.
So here you can see how the Battery is actually kind of the nexus of several of the Lower Manhattan coastal resiliency projects. Our project, which is the wharf, kind of lines the waterfront edge, and it ties up with the South Battery Park City Resiliency Project, this line in orange, and then eventually there will be another project known as the FIDI Seaport Coastal Resilience Project, which will tie back in to Battery Park City's project. So together these projects help to provide the coastal resilience protection for Lower Manhattan. But we made a conscious decision with the wharf project to elevate it to address sea level rise to a modest degree. I mean, we have obviously the ferry program that's very important. There are amazing views to the harbor, so We felt that, elevating the wharf modestly to account for 21 sea level rise was kind of the goal we wanted to set here. So that plus 11, all these numbers are the elevations. So that's about 5 feet above what the wharf was originally. So we'll see some renderings to see how that looks, but that was kind of the decision made at the outset of the project. And here you can see in section how the 5 feet is the pink area. So originally it was at a +6 elevation, and we decided to elevate it up to 5 feet. So that takes into account 2,100 sea level rise, waves, as well as a 1-foot engineering freeboard. And so some of the project goals, as you can see in this picture, it's a really well-used wharf, and so we wanted to make sure we design this as seamlessly as possible and to impact the park as little as possible as well. We wanted to improve circulation to make sure people could find the wharf, and we also wanted to prioritize universal access. And then another key feature that is present at the wharf is this memorial garden known as the Gardens of Remembrance, which was a tribute to 9/11 victims and survivors. You all may know that many people fled to the Battery to get on boats during the event, so this garden was a tribute to that. And so the Stantec team worked really hard to preserve them and to, essentially recreate them to make sure that was kept in the program. And lastly, as I mentioned, the Statue of Liberty ferries depart from the wharf, and they can never stop. It's a 24/7 operation, so that is an interesting aspect of the project, which we worked really hard with EDC and Hunter Roberts to stage the project and to phase it in a way where there would be continuous operations of that service. And I'll hand it off to Amy.
Okay, and I'm sure everyone here is very familiar with this site, but this is the condition that no longer exists because it's under construction, and it's kind of wild to see already the change that has happened at this waterfront. But this is a moment on the waterfront. Rory Price from the Battery Conservancy called it Melville's Coast. It's a moment of evoking the promontory that this place is, the kind of exposure to the horizon of water that is both makes it powerful and beautiful, but also makes it incredibly vulnerable to the impacts of climate change. So we have a waterfront that steps down 2.5 feet in the previous condition. And what we see is that in 2100, which is what we're designing to, 90th percentile projections for sea level rise are showing that our waterfront would be under 2.5 feet of water. And were this a different kind of coast, that might have been okay, but this is an active wharf, as Grace was saying, with constant travel to the Statue of Liberty. And it's not only a future condition. This was January last year, convergence of a king tide and a full moon that resulted in similar kinds of flooding. And I just think this picture is incredible. I think you took it, right?
Yeah, a resident engineer took it, and it was a week before we mobilized, so
yeah,
got very lucky.
But you can feel, it's terrifying. That still body of water is still terrifying, the power of it. In thinking about this project, approaching this project, knowing the significance of this site, a lot of what we were thinking about is what is the impact to views going to be. And so it's not just the view, of course, from the waterfront, but the view from the interior of this space. Anybody who has spent sunset there knows the magic of seeing the glistening of the horizon and the sense of water all around you when you're in the shade of the groves. And so we spent a lot of time looking at the impact of that 5 feet of elevation change. And what was really smart about the way that this was planned out was that at the waterfront, we are shown in pink. Our project is elevating for sea level rise only, so that will mitigate the daily impacts of tidal flooding. But at the back of the park, where we have higher grounds, we are elevating for storm surge. And so that's a separate project. But what that means is that the park is going to flood periodically under certain kinds of storms. It can do that, but property and protection of the city streets infrastructure is happening at the back of the park. So that means on a daily basis, the impact to the view is not going to be completely obliterated. So this was a very early, but ends up being pretty accurate rendition of what that 5-foot elevation change will yield. So you still see the horizon of water; it's still present, and that was really important to us. In addition to wanting to minimize the impact to view, we want to minimize our footprint. So we wanted to save that first row of plane trees. And as we started talking with the Battery Conservancy and understanding all of the different particular intention that went into all the parts of this project, a synergy developed around our evolving sustainability goals, which were happening through EDC's ambition to make this a sustainable project, and then our own desire to think, how can we make this as small of an impact as possible? This isn't a moment where we want to completely transform the Battery waterfront. This is a moment for modesty and the smallest changes possible, as surgical as possible. So we started looking at these materials as maybe these should be the materials for the future site. The scrolls that were very important part of the site and show up in the small details. We even started looking at this wood. You can't replace this with a metal handrail or C-rail and have it feel as romantic and wonderful as this like chunky thing. So we started looking at just the materials themselves, reusing those. And the synergy between those, the design thinking and the sustainability goals made a lot of sense for a project that is a resilience project, that we should be, for the projects that are adapting to climate change, we should also be mitigating for climate change. It just should go without saying. And we know that these don't go together because there's a lot of concrete in resilience work, and concrete isn't the most sustainable thing. So it was a dream situation to have this client, EDC and Parks, fully on board with the experiment that this circular approach, reusing materials, would mean. It was an experiment, and there were a lot of moments of uncertainty that their vision for this to happen carried us through. I'm sure all of us have been part of projects that wanted to do something great, but at the moment of difficulty, we have to just go towards efficiency and get this thing done. This was not the case with this project, and I'm so grateful to have been part of it because of that. So we looked at, in terms of the design, we looked at where could we use this coping stone in the design as a curb, and what could we do with this granite fascia. And so all of those things were incorporated. They were all inventoried and incorporated, and this is sort of the resultant project, which is simply a reversal of the current steps. The steps that were going up 5 steps are going down 5, or that were going down 5 steps towards the water will now be going up 5 steps towards the water. So simple, very small changes. And that this got developed into our Envision program. So we worked with the Envision framework. We were originally, well, just using it as a framework, but ended up getting certified. This was, using it for the certification, I think, was really critical for making us dig deep, not cutting any corners, where we kind of have an intuitive sense of what would be the best approach, but this really made us document and make sure, and it led to discoveries that we wouldn't have had we not been working with the Envision framework. The waste management was one of the places where we focused, and so that started with our material reuse, but also was about making sure that all of the construction materials on the site were diverted from landfills, and that ended up being, I think we have 98% landfill diversion rate. Then, because we did a life cycle analysis as part of the Envision process, the life cycle analysis shows the carbon footprint of all the materials going into the site, and that showed us what we could have already known, that the concrete was the problem. So we looked at and most of the greenhouse gases are coming from the cement. I don't know why this turned black and white, but so we looked at a lot of different standards for concrete. What would be a reasonable, we don't want to make a spec that's going to end up being unworkable. But one of the ways that we got to be really ambitious was by separating the concrete specifications for the different applications so that the sidewalk pavement doesn't have to meet the same standard as the structural marine concrete. And so that way we got to experiment with some of the less critical concretes and set really high standards. These ended up being easy to meet, even though we were ambitious. Another thing that LCA showed us, that life cycle analysis showed us, was that expanded shale was a major contributor. And when we're dealing with these elevating at the waterfront, we are typically dealing with a lot of expanded shale to create that lightweight fill. And but it's a major contributor to greenhouse gases. And so we looked into foam glass aggregate, 100% post-consumer product that is lighter than expanded shale. And the consequence of that lighterness was that we didn't have to excavate as deeply to balance the load. That kept us out of the water table. That changed the construction operations and led to savings, ultimately $3 million, I think, in savings in our process. So you can see we ended up with a combined foam glass and expanded shale fill and much lower carbon footprint. So the last thing I'll speak to is the extended service life, which was one of the Envision goals. And I think this is so important. And working on some of these big infrastructure projects, we tend to have a longer service life. And so we don't even have to think about it. But it's such an important thing that we be designing for durability, that we not be buying clothes to throw away tomorrow, that we not be using plastic forks to throw away right after we eat, and that we not be building projects that are going to have to be redone in 20 years, like build like the Romans. So 100 years is a healthy service life, but I think we could be aiming higher. But working for that service life in consideration of the changes that are ahead of us, many of which we don't know, is that because this is a working waterfront, they have their fleet of boats that are not changing. We asked, is there any chance this fleet of boats might be ready to be cycled out? They were like, no, these things last forever. We worked with the Statue Cruises. And so they have 8 different boats, 8 different freeboards. I think I might have eliminated some of the slides on this, but they already have an accessibility issue. Technically, it doesn't need to be universally accessible, but because we're dealing with tourists from all over, we want to make the boats as easy to get on and off of as possible. But in the near term, some of these boats, you're going to be dropping into them like this, because we're going to be elevating the waterfront so high compared to that elevation of boarding. And you can see the issues that they have depending on the tide currently. So we developed an adaptable slip, which has 2 different elevations for boarding. We couldn't go out in the water. That would have been another option. We looked at a lot of different things. We needed to stay within the footprint of the wharf. And so with these 2 different boarding elevations, the boats are able to calibrate according to where the tide is at the moment and land at the one that is right for them. And in time, the lower one will be able to be adapted. It's designed to be adapted to a higher boarding. And so that allows this whole project not to be rebuilt in 2060 or whatever it would be that this has to be done. So it's a very small, simple adaptation, but it's one of the things that we need to be thinking about to extend the service life. And so our resultant carbon reductions, we were able to get a 54% total carbon reduction and we earned a platinum rating with the Envision. And just a view of this, and we're starting to see this. I was saying we were on the site yesterday. It's starting to look like this, and it doesn't feel as much of a barrier as I was kind of afraid it might feel. It's definitely different. but yeah, we're getting there. And so Ethan is going to talk about the construction complexity.
Awesome. Thanks, Amy. All right. So really going to highlight here, just starting from kind of early onboarding, material reuse feasibility, kind of into just the typical logistical hurdles you're going to see in Lower Manhattan, and really just end with a ton of photos about progress because everyone likes pictures to round out the day or lunch. So moving ahead, this photo was taken back in September, just really kind of highlighting the amount of marine equipment we have to have on site, working on upland, and just the proximity we have to just an active park. On the left side of the screen, you'll see South Battery Park City. We share a fence line, so heavy coordination with their team, which I'll get into later, but really nice overview for the project to kind of get you started. So getting in early, again, this wouldn't be possible without kind of a collective vision between New York City Parks, between EDC, working with Stantec, getting in early to understand what the goal was, how we could be of contribution, understanding what we had to go out to the vendors if we're, say, going for low carbon concrete. Like, who's dealt with this? Are we dealing with standard DVC mixes? Are we dealing with what? A big portion of this is precasted down in Virginia, so these plants really weren't familiar with all the SCMs that we have going on, really just slag and fly ash. But we want to make sure that we're going out to see, hey, this is an achievable goal. We have people that can do this and not limiting our pool. So we're going out to multiple vendors. We're working with Stantec to understand exactly, hey, what requirement can we hit? What is really attainable? Feasibility, a lot of the material salvage, which I'll get into after this, understanding we've all been there. Record as-builts are not record as-builts in most occasions, especially if they're coming back from 46. For us early, we wanted to get in, make sure that if we're pulling off this material, it's built the way that it's shown so we're not having any unforeseen costs. Also, just making sure, hey, is this possible? Is this feasible? The granite wharf that's sitting on the face of a 80-year-old structure, how hard is that going to be to get off? That was a big question mark for us. We already talked about vendor sourcing and market research, and ultimately just working with trades, understanding like, hey, what is a limiting factor here? Where do you see risk? How can we mitigate that risk? What will give you more opportune reason to give us a firmer number? So that's all stuff early on, working with this team that we're like, hey, we're here early, you're developing this, we're developing this together. Again, experimental, and yes, Steve, we are a guinea pig for this, so I mean, it helps out a lot. So as I mentioned, one of the first things we did, I think right when 75s actually got released, was understanding how this was affixed. It was very, very hard. So we realized that we couldn't do it. It's a tidal environment, wave induced. We had to come in at night, and even working off float stages, it was extremely time consuming. The labor drive on this would have been catastrophic. So we knew when we went out, we had to find the most amenable approach to getting this granite off the wharf. Same thing can be said for the upland, which we actually had a little bit more, success in, was that the record drawings were predominantly what the record drawings showed. A few little nuances here and there, but ultimately we were able to verify the constructability of this, so we knew how to take it off and really kind of inform how to put it back on again at the end of the day. So on the left is really that Stony Creek granite on the upland. This is actually a really good picture because one of the things that wasn't really well detailed was the corner conditions. We have solid block abutting a veneer piece, so that helped inform the design of ultimately where we're going to have to use solid block versus veneers. Okay, kind of a little creative solution. And then on the right-hand side is the wooden sea rail, which I'll get to in a photo momentarily, but Amy's original picture really highlighted it. It was in rough shape. We're looking at a tropical hardwood that has been there for X amount of years. It's been dug into by fishermen, by anglers, by anyone, and names carved in it, holes. We wrote off half of this for salvage. We're like, this is too far deteriorated. It's never going to be able to be used. Even working with some wood vendors, we're like, yeah, this is kind of tough. You're not going to really know until you really pull it off and see what the meat and potatoes are like. Really highlighting into the salvage, so started with initial inventory, documenting what's there. This is, picture on the left is the first day. I believe that photo is the second day we're on the job site. So really making quick work. We wanted to get all the delicate hardscapes salvaged off to make way for a marine contractor to come in and do the full-scale demo. Oh, it went back. Oops. A little bit more of the salvage, just highlighting it right there. Immense effort, only trying to remove at the time what we needed to reinstall. Again, document to better inform what has to be procured for the new condition. There's supposed to be something else on this slide, but there's a scroll. And this is really showing also one consideration that we had was when we remove all this, where the heck is it going? We didn't want to transport this off-site. We didn't want to bring this too far away, incur storage costs. Again, we're trying to reduce our carbon footprint here. Keeping it on-site and limiting the reuse, which was really dictated by the design, which Stantec was able to redesign it. And in Amy's words alone, we flip-flopped. Well, that wasn't her words, those were my words. But we flip-flopped the orientation of the benches, but we're maintaining essentially the same actual install conditions. So curbs are going on curbs, retaining walls get the veneer pieces from old retaining walls, granite back bench wall, same thing, just looking the other way. And this is really kind of highlighting just the level of detail that we have our trades doing. It's where those two holes were former bench brackets. Getting those off was a pain because this was one of those nuances we saw from the record drawings where it showed slip anchors. Meanwhile, those were all epoxied in. So we had to over drill. We're like, ooh, that's a little bit not great looking. So we filled them. And also on there is a corner repair, which I forgot it's at the bottom, but we were able to really kind of make the start looking brand new again. So that was pretty cool to see how this is really coming together at this point. And right there is just a dry lay. I have some better photos later on, I believe. But this was earlier dry lay of kind of, hey, what's this going to look like when we do reinstall? Because we had a radial wall. We had some that were straight. We're like, what's the lippage going to look like? Are we within a good tolerance? Or is everyone happy with it? Do we have to go back to the drawing board? But ultimately, it came out that we're like, we have a little bit of room for modification, and we can make this to a very, very approachable design. And we can have this all this material basically reused. So, and one thing to note also for the salvage is that we're reusing, I want to say it was like 96% of the Stony Creek granite. A lot of it that is being recycled is actually going to stone donations and being repurposed, largely because we had a few radials. The stuff we took off, radial in the wrong direction. So, here's what it is. And here's that granite fascia that we love so much. So, the two options we looked at were wire sawing, and then just, again, really that demo that we had to do of the actual wall was on. When we did the early feasibility, it was still an active wharf. We didn't have any stance yet, so we didn't want to destroy the seawall that's protecting the upland area. During demo, we were provided the luxury that we can take out the wall behind it and pull off the stones. So that helped out significantly in getting this off. Wire sawing would have been extremely costly, time-consuming, and then ultimately, if you're pulling out panels, you still had to reface and cut everything off the actual seawall. So this was the most ideal approach for us to pull us off in a reasonable fashion, and it wasn't a cost-prohibitive way of doing it. So, and taking that, which, Amy, did you have the slide about the upper wharf and the lower wharf? I don't know. No? Ah, man. But
It might be in there.
so at these loading slips and along an operator ledge, there is granite cladding that's going to be going on where you actually bore the ferries. So all of that granite that was pulled off of the seawall face is going to be reinstalled, and we actually just started today. And it's going to be, you're able to touch a piece of history as you're boarding these ferries to Statue of Liberty. So it's really cool to kind of see this entire process coming together. This photo is just a representation of one of the mock-ups we had to do, or two of the mock-ups. And that's that C-rail. So we wrote off 50%. I think we had a loss of 3 feet.
Yeah.
So we were working with, again, we had to just go out to a lot of vendors, see who could really look at this in detail, understand, hey, this looks banged up, but the meat of it's really good. So we were able to work with someone, Slatted out of Connecticut, amazing team. They were able to really bring this back to life. So photo on the right really just tells a tale. It's so much life left in that wood. We were able to fill the holes with epoxy, some natural checking that's still going to be there because those will open over time, so there's no reason to fill that. But it's a beautiful, beautiful product. Minimizing our, and this is again towards our Envision goal, is early on understanding what facilities we're pulling material from and also sending material to. So we put together analyses. These numbers have changed because this was initial, but we're still actually at that almost exact target, if I'm not mistaken. I think a little less on the C&D, but we're just about there. But identifying facilities that can receive this material with transloading capabilities, working with trades that are able to actually do transloading. So that's just highlighting that area right there. Am I doing on time? I'm good. And then really just looking into alternative equipment deliveries. We brought 4 or 5 pieces of machines over water. That was pretty cool to see. One of those is a 395. I'm not sure if anyone knows what 395 is, but it's a rather, rather large machine. It was pretty pretty cool to see come walking off a barge at slack tide. So, project challenges. Manhattan's been infilled year after year. For us, we're dealing with 3 levels of infill, so we don't know what's down there, except for in this case, we kind of did. If anyone knows 2 tunnel projects that were going on in this vicinity back between 45 and 50, if you said Brooklyn Battery Tunnel and the Battery Park Underpass, you would be correct. And an interagency, honestly, like possibly the best use of it, they were able to take those excavations, those blast rocks, and use them to extend the shoreline of Manhattan and ultimately the Battery, so providing that riprap fill. So we knew we were going to be going into some rather large obstacles. So definitely a lot to deal with and a lot of underground obstructions, but we knew what we were getting into, so we were able to make informed decisions during our buyouts for that. Also, our proximity. So this photo I really like. It's really showing that we're on the delineation line between an active ferry use. They run every 15 minutes, every single day of the week. The only day they don't work, or I think the only calendar day they don't work is Christmas. But it's working with Statute Cruises, working with National Park Services day in, day out to make sure everyone's happy. If we're doing barge moves, we're not interfering with them. If we do have to say, hey, we got to set up a little bit past the nose, we're coordinating with them ahead of time. And also, it's a very narrow site. We call that the alley. If you're looking down, it's about like 25 feet, 24 feet, give or take, at its widest, or narrowest, sorry. But it's very, very tight conditions. You'll see in a couple photos that it's very tight. So coordinating upland trades and keeping the marine moving to hit our schedule has been definitely a feat of trades working together. Photo just showing kind of how, again, how close we are, how much room there actually is to work. So this is how we're going to install our batters. We're using hanging false work, basically supported off of Deadman, and very close proximity to the park. So whenever we're hitting batters in, we're done with pile driving now, but creating exclusion zones in the park to make sure that everyone's safe. E-crane moves a lot of material very quick. That's a mountain of foam glass. It's about 4,800 cubic yards standing on top, and it's a monstrosity of a machine that was able to offload that within a day. So using some specialized equipment right there, and this is really showing I think it's a 1260 on, yes, 1260 on platform, so on deck barge, and we're able to pull piles, work on the marine demo from there. So having the right tool for the right job. And now these are the progress photos I'm going to go through extremely quick. Salvaging, upper wharf demo, going into the pre-trenching to clear those boulders, create an environment that we can put our sheets into. Sheet pile driving ahead of actual wharf full-scale demolition that's creating a temporary shoreline. Deck demo, pulling off what he's reaching in right now, pulling out timbers, but everything that's shown kind of in the foreground is still on the existing deck, so we're able to pull back from the deck, pull back inland. Pile driving progress, and Steve, if you move your, oh, that was in June, thank you, appreciate it. Again, pile driving through June, cutoffs going into October, working further down. Meanwhile, we also had upland site drainage going in, so we have a ton of under drains, sub drainage, hydrodynamic separators, tide gates. All this is just going on concurrently with the large scale marine. Setting subgrade for all of our foundations, getting ready for our lightweight fill program, installing the bench wall, which is facing now Parkward. Our mountain of foam glass, we're almost finally out of it, so yes. Level and grade, and now we're getting to some more recent events. I skipped a lot in between, really showing the actual lightweight fill placement, and you'll see there's other like curbs, ramps that have been going in simultaneous. But pile caps coming in, all of our precast elements come from coastal down in Virginia, so everything is put on barges, shipped up to the job site. So it's precast piles, sticks, caps, beams, planks, and fascia panels. Setting some planks. This was, I think, earlier last month. Those are the wharf fascia panels that are going on. That is not the reclaimed. That's new granite that's going to be actually in the water. I think at low tide, we are sitting below that lip at the bottom. Granite back bench wall. Looks beautiful. This actually has been fully installed. We're working on jointing it up right now. So next few photos, this was taken over the course of, I think it was like 4 days. So install of fascia panels, reinforcement on the deck, upland work directly behind it, expanded shale on top, and you'll see some pockets of foam glass that are popping up behind. We have some, what was it, a laser pointer? No. But all the granite hard work going in simultaneous, so it's really working our way down the alley and then back out. Deck pour, so that gets us about 40 bents worth, no, sorry, not 40, whoa, 20 bents worth of deck already poured and in place, getting ready for ramps, and just really wanted to highlight just high level of where we started, where we are now. So March during salvage, very big gap in between because we didn't have an aerial photographer then. June, once we had deck demo halfway underway, we have sheet piles going in, and we're just working now on getting piles going. Piles going in July, deck fully gone. Moving ahead to September, again, I think we forgot to call them out to the job site, take photos, but piles going in, full steam. We have upland work progressing extensively, big stockpile, getting ready for transloading. I think that's the same photo again, but I took out the E-crane one, whoops. But in between then and there, we had a E-crane come in, pull out all the soil that went over to Bayshore for recycling, and then they brought in the 4,800 cubic yards of foam glass. Upland foundations going in with deck reinforcement on the left. Overview, so this was taken earlier last week, so that shows that deck placement in place. The upland work following behind, and again, just the amount of marine equipment we have out here on a daily basis. Highlighting, it's really as work's kind of progressing down, we have fascia panels being installed, or beams going in, then fascia panels, planks, and then we're able to follow up shortly thereafter with a topping slab. All the while, all of our upland foundations are happening directly behind us. And that's basically what it looks like current day. We have a little bit more fill going in, and they're working on some ramps and stairs right now. There we go. Sorry, that was long.
Lots of slides. Any questions? Yeah.
Hi, so many questions. First, I guess the big one is, are you planning on doing a publication for any like technical journals? Because I feel like there's a lot of like really specific stuff I want to know that, but I don't want to ask everyone here.
Yeah, good idea. I don't know if that,
I think we've talked about this, but we just haven't had the time yet.
Really think you should. I think
Okay.
there's a lot of
We
things you can teach a lot of people.
we will be taking this onto the road show, so we're at the National ASLA convention this October too. So
Okay. I definitely recommend ASCE
Okay.
also for a lot of like
Yeah, so we do tours with ASC on job sites. I've taken Geo Institute, we've taken COPRI, so if anyone here is part of any organization, young professionals, please let me know, grab me after this. We love doing tours.
yeah, I'd love to hear about like the design life, 100 years. That's like a pretty good target. We're very modest about it. But lightweight accurate.
we're a modest group.
Hi, thanks. I was wondering specifically about the design life extending to 100 years, what that looks like in terms of maintenance.
well, I mean, we're in the fortunate position here of having the Battery Conservancy. So I'm not sure if you're talking about planting or if you're talking about the structures. I mean, and I should say, we're building to 2100, so our design life is technically less than 100 years. But do you have anything to say about that from Parks?
So I would say from the wharf standpoint and the edge condition, that would be maintained via a combination of Parks and EDC Asset Management, who monitors all of our marine structures.
Yeah, I guess I would just say your design life to 100 years, I feel like that's more about, climate change and being adaptable to climate change and being able to go up another few feet and have the boats embark from that point. So from that standpoint, I suppose there's sort of less maintenance because we're not having to elevate the entire thing up to that level. But yeah, I mean, there's still going to be your routine maintenance as we do with all of our waterfront structures and that sort of thing. But I think it will be maybe a little bit of just now that we have these new materials that you're using with the low carbon concrete and so on. I mean, I'm not sure how they weather over time and what their sort of maintenance regime is. That will be something we'll have to, look at with each inspection. Although, I mean, we made sure that the specs, met our spec department. They didn't compromise on structural capacity or anything like that. So.
Yeah, there's an understanding certain things will be replaced over time. Just the whole thing does not have to be rebuilt.
Really great work, all. I'm curious about the foam glass versus the expanded shale, and it seems like you did some sort of hybrid mix, and just wondering why you couldn't go all foamed glass.
Want me to speak to
Answer
that?
Okay.
Yeah.
Ethan loves it.
So if we're thinking about it, so the foam glass, it's low unit weight, it's also buoyant. So why you have to have the expanded shell there is acting as a ballast. So the way the profile really is, it's a 2-to-1 ratio in certain areas. I think we have like one area it's 3-to-1, but you have more dense hardscape on top of it. But as far as the environment it's in, there's an entire buoyancy calc that we had that actually AeroAgrit put together that we use even for interim filling, that we know where our tide level is. If we do have a king tide, we're expecting elevation 3, elevation 4, like, hey, if we have any kind of infiltration, if we backfill to elevation 6.5, elevation 7, we should be good. We'll backfill to elevation 8 with foam glass to make sure that, hey, we're ballasting this down, it's not shifting. But ultimately, we're putting these profiles in simultaneous and making sure that, yes, we'll never have any condition where it's floating out. So the way it is designed is that it can be fully saturated in near 2100 and it's going to be ballast down.
Thanks. This is maybe a question for EDC and for Parks. I'm curious about your interactions with the insurance industry on two fronts. One is, given the high value properties that this is protecting, how will the new coastal protection affect insurance behind the wall? And two, since this is a large scale application of low carbon concrete, and there is interest there in the performance and the long-term performance of this material as well, have there been conversations there to engage them to support their data finding?
Well, I would just start by saying, I mean, this is a sea level rise elevation project, right? So the projects that will be built at the back of the park, those will be FEMA certified. I know at least the South Battery Park City project will be, so I think that will change flood maps and potentially insurance rates. So I'm not sure that our wharf piece kind of has any impact there.
Yeah, and we're not seeking any FEMA accreditation for this project. I think that would be coming either in the Battery Park City Authority or the upcoming Financial District Seaport project. In terms of your second question, I think this is like our first venture into this sort of concrete, so we're collecting our own data, but our Envision Wonderkin over here can...
No, so, I mean, and Dominic will slap me if I'm wrong, but he's not here, so nice. So all these have to go through geotechnical analyses. They have to meet certain conformance, so I have no doubt that those considerations were taken into kind of mind when putting these specs together. Is that, yes, we have a performance criteria that we want to hit as far as a GWP reduction, but also we want to design for this lifespan. If one's going to outweigh the other, I don't think we would ever put something on the ground that it's not going to meet kind of project goal.
Yeah, and I will say we did use the Port Authority specs as sort of our basis because of their advancement in sustainability approaches on their projects.
Great. I think we're missing another lecture that I'm sure a lot of people want to get to. So thank you very much, everyone.